Good morning, everybody. Today we are covering Unit 12.2b, so our second part of 12.2. It is the law of sines. And in this lesson, we will learn how to solve triangles using the law of sines, given that triangles follow AAS or ASA. We'll also be seeing another case as well. We will also find sides and angles using this law, also solving for ambiguous cases. So it's something a little bit new that we're not used to yet, so we'll be jumping into that today. As for our objectives today, by the end of the day, we will hope that students have learned the law of sines formula and how to use it with triangles reflecting ASA and SSA properties. By the end of the lecture, students will be able to solve for triangle sides using law of sines with 75% accuracy or higher. And by the end of the day, students will be able to solve for sides and angles in triangles, including ambiguous cases, with 80% accuracy. So those are our objectives for this unit, guys. We have our warm-up today. Okay, I know everybody is so used to doing these warm-ups, they may get a little bit annoying, but I've got the link pasted in there for you. We're going to review practicing solving our special right triangles, just like we did in the last lesson. So you can answer on Kahoot, preferably in your free time in class that we'll have today, but post it by tonight at 8 p.m. if you can't finish in class, okay? It's just this one question. You're going to solve all sides of the triangle. Do what you can, find all the sides, all the angles, and I want you to tell me what they are. And then Kahoot will give you multiple choice questions to answer, okay? Fill in the blanks. So solve it before, log on, and answer those questions. All right, diving into our law of sines. The law of sines can be used to find side and angle measures given two angles and any side. So either in format AAS or ASA, or two side lengths and an angle outside of them, which is SSA. So this is the other form that we're looking at today. Our law of sines is as follows. We take the sine of angle A over side A, and we can set that equal to another part, and that's the sine of angle B over side B. And same thing, set that equal to the sine of C over side C. Okay, so it's a lot easier than it sounds, and you can use any piece of these. So say we're given A and B, we can use only pieces A and B and set them equal to solve a missing piece. So I'm going to show you what that looks like right now. So our directions on our homework will be to find each missing measure and round all answers to the nearest tenth. Okay, so let's set this up using our formula. So remember, it's sine A over A, sine of B over B, sine of C over C. So what do we have here? So we can do sine of 34 corresponds to the 10 across, okay? And then the same thing, the 52 corresponds across to the x. So we can do sine of 34 over our 10 equals sine of 52 over our x, because x is what we're looking for. We don't know what x is. Okay. Now we can cross multiply, and we get x times sine of 34 equals 10 times sine of 52. And how do we get that x by itself? Just pretending like it's a normal number, we can divide by the sine of 34 because that x is just multiplied by it. So if we divide by it, it should nicely cancel that sine of 34 out. And all you are left with is x equals 10 sine 52 over sine of 34. Okay, and we would find there that x, after typing that into our calculator, is 14.1. So those obviously aren't normal sine functions that we're used to seeing on our unit circle, but that is something that we can do in our calculator, and you know I allow that. So you can feel free to go ahead and try that. We're going to also cover number 2, okay? And we're going to see the same thing. So you look at the side across from the angle. So the 119 degrees and the x coincide just as the 21 and the side 7 do, okay? So keep that in mind when you're setting up your law of sines. Now, on your homework, I will have you solve for different pieces, sometimes just the x and sometimes all missing sides and angles. So we got to keep that in mind, okay? But in this case, we are just looking for the missing x. All right, so our first one we are going to set up as sine of 21 degrees over 7 equals sine of 119 over x. And we can do the same exact thing, just like the last problem, where we get x times sine of 21 equals 7 times sine of 119. And we will simplify it the same way. You can divide by that sine of 21. Divide by the sine of 21. So you have x equals 7 sine 119 over sine of 21. And if we type that into our calculator, we're rounding to the nearest tenth. Remember, don't forget the nearest tenth on our homework. We would get x is 17.1. Okay. Let's move on to the next topic, and that is finding sides. Okay. So we've got a little bit of a picture to kind of demonstrate how we can continue finding sides. So we were finding sides and we're going to continue, but this time we have a little bit of a story. So let's answer number 5, for example. How far is Kevin from Adam? And it tells us that Kevin, Adam, and Dan are passing a hockey puck. Okay, so they're making this nice little triangle shape. And we can see that between Adam and Dan, there's 25 feet, okay? So if we look across from the 86, opposite from the 86, we've got 25 feet. And if we go across from Kevin and Dan, from that 71, we're getting that distance between Kevin and Dan. Okay, and that's the one that we don't know. We also don't know what is across from Dan over here, okay? And that looks really crazy. It's starting to look a little crazy, but we can just label it X and Y. Okay, so in this first one, we want to look at the space between Kevin and Adam. We want to look for X in this case. Now we're missing some information we need. We need to know what Dan's angle is here. So we know that a triangle adds up to 180, so we can subtract the 71 and the 86 that we already know we have, and we can get 23 degrees. So we know that Dan's angle is now 23 degrees. Okay, and we'll use that in our setup. So now we know that 23 and X go together. So we have sine of 86 over 25 equals sine of 23 over our X, because that's what we're looking for. We're looking for that distance between Adam and Kevin. And if we cross multiply, we will be able to set up a simpler ratio of X sine 86 equals 25 sine of 23. And same thing, just like we did before, we're going to divide by that sine of 86. Divide by the sine of 86. And that will cancel our lovely sine of 86 on the left-hand side. On the right-hand side, we are left with 25 sine 23 over sine of 86. And if you put that in your calculator, we get that their distance is 9.8 feet. And we know it's feet from the feet it gave us for the 25. Okay, I'm going to leave number 6 for you guys to do on your homework, just like I did with numbers 3 and 4. But we are going to look at a little bit of definitions here, a little bit of review. Okay, so finding angles, SSA. Watch out, when finding angles, it is possible to have one solution, two solutions, or no solution. This is called the ambiguous case. The sine function always ranges between -1 and 1. Okay, so we got to remember that. If the sine function is positive, then the angle will lie in quadrant 1 or quadrant 2. So remember, when we have our quadrants, we can go, okay, all students take calculus, and that helps us remember what's positive. They are all positive in quadrant 1. Sine is positive in 2. Tangent's positive in 3. And cosine is positive in 4. So we want to remember that right now we're just looking at sine. So quadrants 1 or 2. To find the other possible angle, we can subtract from what adds up inside? 180. The sum of the angle measures in a triangle is also always 180, and no triangle can have two what? So what are our super wide angles? They cannot have more than one obtuse angle, okay? So that's the one that's more than 90 degrees, okay? Keep that in mind. Let us practice finding an angle here. So first, let's set up a lovely triangle for us, okay? So if we draw a lovely triangle here, let's set up an A, a C, and a B. And we know that angle A is 50 degrees. So we got a little 50 in there. We know that AB is 4, and we know that BC is 9, and they want us to find angle C. So I'm gonna label that as X. That's what we're looking for, okay? So we can use what we know to find these things. So sine of 50, using our law of sines, over the 9, because it's across from the 9, equals sine of X over 4, because it corresponds across from the 4, okay? Now, if we do our cross multiplying, we have 9 sine X equals 4 sine 50. Now, something looks a little different here. This time our X is locked inside with our sine. Okay, we have to remember that. We cannot just divide by it, but we can divide by a 9. Okay, so if we divide by 9, we can get sine of X equals 4 sine 50 over 9. Now, this is where we have to use our inverse sign. We practiced using our inverse sign a couple days ago, okay? So your inverse sign of 4 sine 50 over 9 would give you what X is. And in this case, X is 19.9 degrees. Now we just have to double check for ambiguous cases. And in this case, we do 50 plus whatever our possible remaining things can be. So we found 19.9, and that's less than 180. Yes. Okay. And then what would we have left? We would have 50 plus 160.1 is greater than 180. So that does not work. Okay. So we have to be very careful checking for our ambiguous cases. All right, we are going to review a little bit of information before we move on, just because I want you to have your little recap, and we'll continue after our break, okay? Don't forget your Pythagorean theorem. Write it down if you don't have it written down. And don't forget your SOHCAHTOA. Remember, this is a great way to remember. Sine is opposite over hypotenuse, cosine adjacent over hypotenuse, and TOA, tangent, opposite over adjacent. Okay, it's a great way to remember. This is our law of sines, so we are keeping in mind that we can flip these over. That's totally fine as long as they all do. But you also need to remember that all angles of a triangle add up to 180, okay? Do not forget it, please, please, please. I also linked a law of sines review video, okay? It is open, it goes straight to YouTube. It is a great video to watch to review ambiguous cases and everything. And your homework is to be ready for our number talk on the next day that we meet. Please, please, please complete 3 of the 5 activities for your homework, as well as your ticket out the door assignment. You get to pick, okay? 3 of 5 of these assignments, but do not forget that does not count your ticket out the door assignment. That has to be done. It does not count as your one of your 3, okay? But you can complete Unit 12.2 Homework 5, which is part of your packet, and a great review for the test because our test questions will be based on that. You also have the choice to create your own 2 triangles that show the difference between ASA and AAS. You can play this game. It is a great way to review law of sines. All you have to do is click that link, play the game, submit a screenshot of your scores, okay? And I want you to play it until you can get at least 80% accuracy, okay? 80%, please, please, please. You could do definition organizers for your terms, which I'll show you on the next slide. Or you can complete the 4 problems on the Khan Academy link and submit a screenshot of your scores and your work for the problems, okay? So there's the link for that as well. Here are your Freyer organizers for your terms, okay? So it has critical characteristics, your non-critical characteristics, okay? Examples and non-examples, okay? And then the middle, the concept would be your term. So if you want to draw a picture, you can draw a picture. You can show me ways that it is not, okay? So you can draw incorrect triangles. You can really do whatever you want here. It's more for you to find ways to remember what these terms are and how you can use them. And same thing for examples and non-examples, okay? So use words and pictures. And these would be your terms that you would be doing those organizers for. And then for your ticket out the door assignment, I want you to submit your work as an image for your TOTD for lesson 12.2b. Find the other angles using the law of sines. Okay, and that is it for today. I hope that you guys have a great weekend, and I will see you on Monday.